Hello friends and welcome to this period again. I am Shekhar Deshmukh, your science teacher. In last period we have seen about the syllabus, marking scheme and paper pattern of science part 1 and part 2. From this lecture we are going to start our syllabus. Our first chapter is gravitation. Friends, last year we learned about the different types of forces and gravitation also. So let us recall our knowledge. The first question here in this textbook, we go through the textbook. The first question which is asked here, it is what are the different effects of force on an object? So we learned about force and what should be the effect. Suppose the ball is placed here on this table or the duster is here. Here it is stationary. If I apply force on it, look, if I apply force on it, then definitely some effect we can see there. So what is the effect? The stationary object, it sets into motion, that is the effect of force. There are such many effects of forces. Suppose any object is there, if it is already in motion and if I apply force on it, then definitely the object, it come into rest position, that means it stops, or it may changes its velocity, that means it may changes its speed or direction. So that should be the effect of force. One more effect of force that we have learned in last year. This is an object, this is a ball. If I press this, that means if I apply force on it, then it changes its shape. So these are the so many effects of forces. The second question which is given here, that is what are the types of forces that we are familiar with? Friends, there are so many types of forces. I am applying muscular force here. So muscular force is there, magnetic force is there, electric force may be there, gravitational force is there. So there are so many types of forces. The last question, what do you know about the gravitational force? Friends, we already learned that the gravitational force is a long distance force. It acts on any two objects. That means if there are, it acts between any two objects. Suppose this is A and this is B. These are two objects. Then gravitational force acts between these two objects. It is the attraction force and it is a long distance force. That means not only on Earth but in the universe. In the universe, any two objects, if they are there, then the gravitational force acts between them. So this year, first of all we see how this gravitational force is discovered. A very interesting story is behind that. You can see the photograph here. In this photo we can see that Sir Isaac Newton, he was sitting under a tree of apple and suddenly apple falls from the tree. There are many questions arises in his mind, that why this apple falls down only, why it falls perpendicular to the surface, that means why it falls in vertical direction, why it doesn't make or why it doesn't fall making an angle with the surface, or why it doesn't go horizontal to the Earth's surface. Look, suppose this is Earth and the tree is shown here in the picture. But suppose if the tree is present here and if the apple falls down, we can understand it very easily. Interesting to know. why it doesn't fall in this direction, why it falls in this direction. That was the main question arises in his mind. And he thought that there must be some force of earth which attracts that apple towards the center of the earth. So the apple, it never falls by making an angle, but it always falls perpendicular to the surface of earth because it gets attracted towards the center of the earth. Then he thinks there are so many apples which are present on this tree, and every apple falls in this direction. That means definitely the force of attraction, it is on every apple. Then suppose there is any object present here, then whether the force acts on that also? Definitely yes. This object also falls on the earth, and the falling direction is toward the center of the earth. The direction toward the center of earth, it is always perpendicular to the surface of earth, and therefore each and every object falls vertically downward. That was the gravitational force. This is how he discovered gravitational force. Then he thinks, there are so many objects in this universe. The nearest celestial body, it is nothing but, suppose moon is here. So he thinks whether the same gravitational force is there on moon also, whether the same gravitational force of earth is there on sun or other planets in our solar system and other solar systems. So whether there is a force between them. Definitely we say that the gravitational force is long distance force, therefore it definitely acts on moon also. Then why moon doesn't fall? If we see it, if the force is applied, then definitely the motion, the force is related to the motion. It changes the direction, it changes the speed, or it changes the velocity of the object. Then definitely if the moon is not falling on the earth, but the moon is moving around the earth, then definitely there must be some relation between the gravitational force of earth and the motion of moon also. Friends, we see, last year we see the three laws of motion, Newton's three laws of motion that we see. Let us discuss about that first. What are these three laws? Newton's first law is, every object, a stationary object or whether the object is in motion, it remains in the same state of rest or of motion unless an external unbalanced force acts on it. That was Newton's first law. The second law is about momentum. The rate of change of momentum is directly proportional to impressed force, and it acts in the direction of force. We know that. The third law, it is about action and reaction force. To every action, there is equal, opposite and instantaneous reaction. So these are the three laws of motion. That means definitely there is a relation between force and motion. So let us discuss about the motion of moon around the earth. So which type of motion is it? It is definitely the circular, because the moon, it revolves around the earth in a particular orbit. So what is meant by circular motion? Let us see circular motion and centripetal force. What is meant by circular motion? If the object is moving around particular center in a circular path, then it is circular motion. And let us see which type of force is acting on it. Simple activity. This is a ball. I hold it in my hand. So whether I am applying any force on it or not. Definitely a force is applied by me. Because if there is no force, then definitely it eventually falls downward due to the gravitational force. But I am holding it. So I am applying force on it. So what is the direction of that force? Definitely I pull this ball towards my hand. So it is in upward direction. The force must be in upward direction. But if I rotate it in this way, then now tell me the direction of force. Definitely it is towards my hand. That means it is to the center of the circle and the ball is revolving in a circular orbit. So if any object, it revolves in a circular orbit, the force, the direction of force, it must be towards the center, towards its center. If I rotate it, then definitely the ball, it revolves in a circular orbit and the ball, the direction of the force, it is towards the center of that circle. Let us see. Suppose this is a ball. It revolves in this direction. Then it revolves in a circular orbit. And the direction of force, it is towards the center of that circle. So this is the direction of force. Now let us think about the direction of motion. What should be the direction of motion? If I leave this ball, then whether this ball, whenever I leave it, while revolving, whenever I leave that ball, whether it comes towards the center? Definitely not. It never comes to the circle, towards the center. Then in which direction it goes? The direction, for that we have seen one experiment also of a disc, rotating disc. If we rotate a disc and place a coin on it, then definitely the coin goes off from it in a tangential direction, in different direction. That direction is tangential. Like if I leave this ball here, then it must go in this direction. If I leave this ball at this position, then it definitely goes in this direction. If I leave it here, it goes in this direction. If I leave it here, then it goes in this direction. So the direction of motion is always tangential to that point, to the circle. So one very interesting question is asked here in this book. Look, if the moon definitely moves in a circular path due to the force of attraction, that is the gravitational force of Earth. If suddenly the force disappears, then in which direction the moon goes? The definite answer is the moon, it definitely goes in a direction tangential to that circle at that point. So friends, in this small video, we have learned what is gravitation. Gravitation, it is a long distance force acting between any two objects, not only on Earth but in this universe. Any two objects I am saying, that means this is the ball, this is the duster. There must be the force of attraction between these two also. And this force of attraction is nothing but the gravitational force. small thing sometimes we misunderstand. If I leave this ball, it falls on earth, we say it is due to the gravitation. Definitely it is due to the gravitation, but at the same time the ball also pulls the earth towards it with the same force. That is nothing but gravitational force. But the reason is only the mass of the earth is very huge, and therefore the earth doesn't come up, but the ball, it falls down. It is the issue of mass only, but ball also pulls the earth with the same force, because gravitational force is the attraction force between these two objects, A and B. Suppose these are two objects, the gravitational force is nothing but the force of attraction between these two objects. So in this lecture we see what is gravitational force, what are the effects of force, what are the Newton's laws of motion, and what is circular motion. And one very small thing, that is what is centripetal force. Friends, centripetal force, it is nothing but center seeking force. That means any force, if the object is moving in a circular path and the force of attraction is towards the center, then definitely it is the centripetal force. So centripetal force, it is nothing but center seeking force, or the force directed towards the center. So the direction of force is towards the center. So it is nothing but centripetal force. Okay friends, in next video we will discuss about Kepler's laws. Thank you.